Hello. Noise in the background often introduces difficulties in listening. Previous studies have shown that such difficulties may lead to mishearings, misunderstandings, and even communication breakdowns in extreme cases. Thus, error mitigation strategies such as Lombard speech are quite useful in such adverse listening environments. However, studies on Lombard speech showcased evidences that the benefits do vary with other linguistic factors such as predictability. In this work, we proposed an alternative error mitigation strategy based on lexical paraphrases. Our hypothesis is that by replacing lexical units with their noise-robust synonyms, comprehension errors introduced by mishearings can be reduced. So at first, to validate our hypothesis, we conducted listening experiments, and based on the experiment data, we defined a score called a human recognition score to measure the intelligibility of a particular word in a listening environment. It's basically the proportion of correct recognitions among the total responses. The value ranges between 0 and 1. Since we are interested in finding the impact of lexical replacement in comprehension, we also calculate the difference in HRS between a word and its synonym. Let's see what did we find from our first experiment of presenting synonyms without any linguistic context. With the increase in background noise, there's a steady increase in number of synonym pairs that are distinct in their recognition scores. Now, we were curious about what would happen if synonyms were presented with linguistic context. And from our experiment, we were able to see that a very similar pattern like the earlier listening experiment. More precisely, at high noise environments like babble SNR -5, there's higher gain in intelligibility by lexical replacements. At this point, we were curious on understanding what are the driving factors for this difference in intelligibility scores, and we investigated with some modeling experiments. And interestingly, what we saw was that at SNR -5, it is the acoustic features of the synonyms that drives the intelligibility difference rather than the linguistic features contributed by the context or the phoneme length of the synonyms. Thus, to summarize, in this work, we proposed a novel strategy based on lexical replacements for improving comprehension in noise. And we observed such lexical replacements exhibited a maximum gain in comprehension at high noise environment of SNR -5. Finally, we investigated different features that drives the intelligibility differences at different noise levels. Thank you.